After studying this module, you shall be able to learn about the human capital and new economic theories. Also, understand the concept with the help of case study on human capital and new economic theories. The concept of human capital has played a significant role in the new economic growth theories. These theories are associated with Lucas and Romer. There is a positive link between investment in education as a human capital, labor productivity and earnings or wages, which can be examined theoretically and empirically. Let's look at the human capital and new economic theories. There is a positive link between investment in education as a human capital, labor productivity and earnings or wages, which can be examined theoretically and empirically. This link can be shown as increase in education leading to increase in human capital, which leads to increase in productivity and ultimately leading to increase in wages. Along with this sequence of positive relationship between the variables, creation, acquisition and application of knowledge and skills also have an important role in the determination of economic activity and growth at the macroeconomic level. In the human capital theory developed since early 1960s by Mincer, Schultz and Becker, there is a positive link between knowledge and productivity. This positive link of the human capital theory is used in examining the knowledge embodied in the factor inputs of physical capital and labor in the path of economic activity and growth in the context of new growth theories since late 1980s. To understand systematically, we can first begin with the production function of economics. That is, Q is equal to function of K, L and Rm. Let this be equation number 1, where K and L stand for physical capital and labor, and Q and Rm denote output and raw material. Increase in the level of output can result by either increase in the factors of production and efficiency of factors, that is improvement in productivity of the use of factors, or both. Total factor productivity, that is TFP, is defined as the difference between the growth of outputs and the growth in the inputs or factors. It is assumed that A stands for productivity or technical progress, as they are both components of growth accounting residual, which is that change in output that cannot be explained by changes in inputs. Therefore, we can write as under delta A by A is equal to delta Q by Q minus, within brackets, delta K by K plus delta L by L plus delta Rm by Rm. Let this be equation 2. The delta A by A is the productivity or technical progress, which is an extremely important indicator of the new growth theory. For the time period between 1948 and 73, some 40% of the growth of national income in the USA was accounted for by changes in factor productivity, as study done by Chattopadhyay in 2012. The labor productivity growth contributed 50% in the growth rate of GDP per capita in most of the countries. Rise in the average education levels boosted productivity in most of the OECD countries. The question arises that from where does this increase in productivity come in most of the OECD countries? Human capital theory had partially provided a theoretical answer to this question, but not an empirical one. The economic growth in potential income was 3.8% per annum in US during the time period of 1948 to 1973. In the US economic growth rate, 15% growth is contributed by capital, that is K, and 15% by employment and working hours of labor, that is L. 14% growth has been due to the capabilities of workers with more education. 10% is due to improved resources allocation, and 37% growth was contributed by advancement in technological, managerial and organizational knowledge. On the same lines, the role of TFP in the US, the human capital has contributed 0.5 percentage points of annual economic growth of US during the two decades, namely 1950s and 1960s, and about half of that during the slowdown of the 1970s. In the case of UK, the role of human capital was higher in influencing productivity growth over the period of 1928 to 68. The crucial point for the new economic growth theory was the human capital induced productivity technological change. The new growth theories also explain whether the technological progress takes place endogenously within the economic system or exogenously outside the economic system. Traditionally, economists have explained that exogenous technological progress is the result of the scientific breakthroughs or revolutions enhancing productivity. Solow in 1956 provided the exogenous reasoning for economic growth in an economy. Solow's model treated A as an exogenously provided public good, free available to the firm. The novelty of the new economic growth theories propounded by Lucas and Romer was that knowledge and ideas, including human capital, which can enhance technological progress and productivity A, is determined endogenously. Indeed, knowledge was treated as a factor of production. Output is regarded as a function of the stock of human capital in the Lucas model of economic growth. The concept of human capital is more accurately defined as knowledge. Therefore, growth could be fueled by the better quality of education. There is a debate whether the quality of education improves over time in order to facilitate growth, but there is no complete explanation for how the quality of education can improve continuously. There are four basic inputs in the Romer growth model, that is physical capital K, labor L, human capital and level of technology. The macroeconomy is molded in terms of having three sectors which are related in the manner suggested in figure 1. That is, research sector uses human capital plus existing knowledge and produces new knowledge, that is, ideas, designs and patents. 2. Intermediate sector uses new ideas and produces capital goods, that is, machinery and software. And thirdly, final goods sector uses the capital goods and produces final goods for consumption. Romer's endogenous growth model. Human capital and the level of technology related to the ideas are two aspects of knowledge as factor of production. Human capital is taken to be the cumulative effect of formal education and on-the-job training. This is treated as a rival rather than a public good in the sense that it cannot be increased on a per capita basis without end. Human capital is inseparable from the individual human capital investor. Each person has only a finite number of years within which to acquire knowledge and skills, and that human capital is lost when a person dies. On the other hand, the level of technology and ideas are non-rival in that their growth is unbounded. As Romer in 1990 observed in relation to death, any non-rival good that this person produces a scientific law, a principle of engineering, a mathematical result, software, a patent, a drawing or a blueprint lives on after the person is gone. Thus, Romer has separated the human capital component of knowledge, which is rival in form, from the non-rival technological component of knowledge. A crucial component of Romer's model is knowledge costs and their effects on the intentional decisions of education by students and families. At the micro level, the costs of education for gaining human capital are incurred by students and they sacrifice the present consumption of other goods and services. At the macro level of economy, the whole human capital and knowledge is general, is not an exogenous windfall gain, but the human capital is a key factor of production which is intermingled with the generation of new ideas and knowledge. Therefore, the conclusions of Romer's models are: 1. The stock of human capital determines the economic growth rate, and 2. Contribution of human capital into research is an important determining factor for higher economic growth. Romer also explained that a one-off increase in the stock of human capital above a certain threshold level can increase the economic growth indefinitely. For examining these conclusions of Romer's model, an empirical analysis of research and development spending is undertaken with table 1, and the source of data is OECD. The first column of table 1 depicts the names of countries, and the second column shows the level of research and development spending per capita in different countries. The third, fourth and fifth columns depict the gross research and development as percentage of GDP, the percentage of R&D financed by the industry and researchers per 10,000 of labor force respectively. These values and percentages of R&D of different countries are also shown in figure 2, 3 and 4. The table and figures show that higher R&D spending positively affects the stock of human capital in the listed developed countries from the UK to the US. The R&D spending per capita in UK was lower at $362 and highest in the US at $730. Similarly, the number of researchers per 10,000 population in the UK was lower at 50 and higher in the US at 74. However, the Japan had the highest number of researchers per 10,000 people, which was 92 in the same year. The percentage of R&D spending in total GDP of that country was less than 2% in the UK at 1.94% and more than 2% in the US at 2.62%. However, the highest percentage of R&D spending in GDP was invested by Sweden at 3.59%, which was close to 4%, almost double of the UK spending. The percentage of R&D spending financed by the industry is important to analyze here. Therefore, it can be inferred from the table and figures that 47% of total R&D spending in the UK is done by the industry, and it was 63% in US, and highest industrial investment in R&D spending was 78% in South Korea, which was very near to the second highest of Japan at 73. Along with the US, this higher R&D investment by the industry in South Korea and Japan proved them as Asian tigers in terms of higher contribution of human capital, though more for achieving higher labor productivity, economic growth and development since 1960s and 1970s. This has also been illustrated in form of a diagram. In the above paragraph, we have examined the higher level R&D investment for the analysis of human capital formation. Now, the broader macroeconomic effect of higher human capital formation is examined through analysis of labor productivity in some developed countries as shown in table 2. The index of labor productivity in the selected 6 countries is given for the 6 years, that is 1913, 1938, 1948, 1973, 1988 and 1998, using the labor productivity in the US as a base. So let's look at the index of labor productivity, where USA is equal to 100. For the 6 periods 1913, 1938, 1948, 1973, 1988 and 1998. For USA, the base is 100 for each one of the years. For France, it was 42, 47, 36, 66, 83 and 103. For Germany, 50, 55, 30, 66, 82 and 90. For Italy, 43, 47, 33, 65, 78 and 100. For UK, 78, 74, 58, 62, 73, 81. And lastly, for Japan, it was 20, 36, 16, 51, 71 and 70. The same has been depicted in the form of a diagram. Table 2 and figure 5 depict that higher labor productivity is there in the US since 1917 and it still continues. However, some countries like France have exceeded the labor productivity in the US in 1998. The value of index of labor productivity in France was 103 in 1998. Italy also touched the level of productivity of US. Therefore, the value of the index was 100 in 1998. These higher levels of productivity in France and Italy can be identified as catching up effects with the US for France and Italy. Japan gained its momentum of higher productivity in 1973, which was 51, and it has increased to 70 in 1998. In terms of labor productivity, most of the developed countries are still lagging behind in comparison to United States of America. Let's look at the case study of human capital and economic growth in Canada. Human capital investment is an important factor of the economic growth story of many economies. Search and Tremblay in 2001 examined the convergence of per capita income through higher role of human capital investment. Canada is an open economy with freer trade and capital between various provinces. Colombe and Tremblay used the data of the Canadian census of 1951, 1961 and 1971, and for a gap of 5 years up to 1996. That is 1976, 1981, 1986, 1991 and 1996. Colombe and Tremblay explained a pattern of convergence of the 10 Canadian provinces in terms of university education in the period from 1951 to 1996. The names of provinces that had higher initial human capital stocks of graduates, that is Ontario, British Columbia, both of them have moved much closer to the average by 1996. The names of provinces with higher per capita income, that is Ontario, British Columbia and Alberta, tend to have a better educated population. In general, the names of provinces with lower per capita income, that is Newfoundland, New Brunswick and Prince Edward Island, are below average in terms of educational achievement. Saskatchewan and Manitoba, two provinces with per capita income close to the province average, have educational achievements close to the province's average, have educational achievements close to the average. Furthermore, the indicators of human capital have grown faster since 1951 in the provinces that were originally less endowed with human capital. The speeds of the convergence of per capita income are much faster for the 15 to 24 years group. If investment in human capital is the driving force of the convergence process, the slowness of the catch-up process could be attributed to the fact that important portion of the total population does not have a clear incentive to invest in education. The opportunity cost of investing in education is usually higher for the population over 25 years of age, and the expected return on the investment decreases when a person gets older. Colombe and Tremblay asserts that the neoclassical model of economic growth of human capital accumulation explains around 50% of the convergence across Canadian provinces since 1951. The important determining factor of this convergence was the dynamic accumulation of human capital. This factor corresponds with the Barrow and Salai-Martin and Barrow findings that higher investment in education is one of the crucial factors of the long-run growth in an economy by using cross-country data. On the same lines, the human capital catch-up process explains roughly 50% of the relative growth of per capita income since 1951 across the Canadian provinces and more than 80% of the relative income levels. Despite the relative scarcity of physical capital in the poorer regions, capital did not flow to these regions because the availability of a well-educated population is a necessary need for the productivity of the machines. Since a section of the population is young in some parts of Canada and it has an adequate incentive to invest in education and have faster catch-up effect to reach the average per capita. However, in some parts of Canada, the catch-up effect of human capital is slowed down by the stock effect of the less educated older people and could not reach the average per capita and remains in the poor regions. The catch-up by the poor provinces has been assisted by the higher roles of public services. There was a rise in the welfare state and the creation of massive inter-regional redistribution programs. For example, joint financing of public spending in education in some of the regions of Canada. Just after World War II, per capita income disparities across the Canadian provinces were much larger than those observed across the US border states. Economic development seems to have spread out more evenly just south of the border, partly because of the phenomenal public investment in secondary education in the far west, the Great Plains and parts of New England between 1910 and 1940. The general message of this case study is that education matters for economic growth even in the developed global north countries like Canada. A study on the US labor productivity growth between 1950 and 1989 shows that there was a secular decline in the labor productivity, other things remaining constant, which in turn adversely affected the US productivity growth. This period, that is 1950 to 1989, was identified as slowdown in US productivity growth. This slowdown in US was not due to the decline in labor productivity, but due to the persistent decline in an important determinant of output per worker. The improvements in labor quality in the US were intermingled with the human capital framework. In case of developing economies, the role of human capital in economic growth is both clear and important. Smith differentiated the human capital in the economic growth in Philippines and South Korea during the period 1960 to 1988. The economic growth rate in Philippines and South Korea was 1.8% per annum and 6.2% per annum respectively. Robert Lucas explained that the main engine of growth is the accumulation of human capital and knowledge. The differences in human capital between the economies determine their standard of living. The previous sections examined the productivity or efficiency as the main determinant of economic growth. Increase in labor quality and better technology positively affected the productivity of nations. Romer also explained on these lines that labor quality and new technology are the two crucial factors of knowledge, that is, human capital and ideas. A country with a large stock of human capital has a large economic growth potential. Any country which invests in higher knowledge formation in the research sectors actually contributes to higher economic growth, including higher current consumption and for saving and reinvesting in the future growth of knowledge. Let us summarize what we have done so far. This module examined the productivity or efficiency as the main determinant of economic growth. Solow provided the exogenous reasoning for economic growth in an economy. Solow's model treated A in the production function as an exogenously provided public good, freely available to the firm. The novelty of the new economic growth theories propounded by Lucas and Romer was that knowledge and ideas, including human capital, which can enhance technological progress and productivity A, is determined endogenously. Indeed, knowledge was treated as a factor of production. Increase in labor quality and better technology positively affected the productivity of nations. Romer also explained on these lines that labor quality and new technology are the two crucial factors of knowledge, that is, human capital and ideas. A country with a large stock of capital has a large economic growth potential. Any country which invests in higher knowledge formation in the research sectors actually contributes to higher economic growth, including higher current consumption and for saving and reinvesting in the future growth of knowledge.